we estimate there's still 300,000 logs floating on Spirit Lake. That's interesting. And of course, one of the projects Steve Austin did, and I went with him crazily enough once, never again, was to go out there and examine the species of logs floating on the lake to see if, in fact, the species change through time. And the conclusion was that most tree species, actually get waterlogged and fall down to the bottom of the lake very quickly. There's only one species left. It's only Douglas fir. And we estimate that the Douglas fir flotation time, the half-life of the flotation time of the Douglas fir is 75 years. We expect that stuff will be floating for centuries following the flood. It doesn't even want to go down to the bottom, to use my roommate's terminology. It likes being on the surface. That's amazing. Well, think about what this means for the flood. If the flood takes out the world's forests, not just 256 square miles of forest, the world's forest, some of those are going to be buried immediately. Some of those are going to be ripped up and crunched and decimated. Others are going to sink down pretty rapidly. But I would suggest by the end of the flood there would be billions upon billions of trees, logs, floating for centuries following the flood. Now this is interesting. Because, of course, what we have in the present Earth is we have the winds of the present Earth are creating currents. And if there were billions of logs floating on the oceans, these logs would be turned, it would be a huge log raft, basically, all over the oceans, allowing organisms to transport not just via land, in other words, coming from Ararat across the land to the various locations, but they ought to be able to jump onto a log raft and make it across oceans in that way. And this realization, the reason I actually developed the idea was because I was trying to explain organisms that are found in what's what we call disjunct populations. Here's an organism that is found in these places. How in the world does this organism, this is a freshwater crustacean, not a saltwater crustacean, it's an entire family that's only found in these places, nowhere else on the planet. How did it get there? Plate tectonics doesn't explain it because it connects the wrong things here, connects these two things, but doesn't connect Australia with them. Maybe if you go back to where they are all together in the Permian, but this family actually dates from more recently than that, so plate tectonics doesn't explain it. But they're all sitting on the same current. There's a bunch of things on either side of the Atlantic, and of course that's typically understood. Before 1916, it was a mystery. Beginning in 1916, they began to describe it by plate tectonics. So the things across that ocean, they explain that way, but there's just as many things on both sides of the Pacific Ocean. So, plate tectonics only explains those across the Atlantic. It doesn't explain those across the Pacific. But there are just as many across the Pacific. So I suspect that this is a mechanism to explain, and there's all sorts of fun things. This isn't a talk on that, so I'm not going to dwell on the predictions and the expectations, and it's exciting. But this is part of that post-flood world, wild world before the flood. Simultaneous with this, because you've got to get all the organisms there, but you still got to, how do you diversify them? Is there evidence of this diversification? Of course, part of the evidence of the fact that there has been a recent diversification of species is the fact that species in the present can be crossbred successfully. By the way, and I'm going to put a parenthetical note in here, this is one of the most interesting biological conundrums, I think, of the last, I'm going to say, 2,000 years. There's someone by the name of Aristotle who told us that species cannot interbreed. And we've believed it ever since. That myth has persisted, and he uses and Aristotle himself used the mule as an example. See, when you cross the horse and the donkey, you get a mule which is sterile. Otherwise, you just can't cross two different species. It's impossible. It was believed by Aristotle, and of course, because of that, it was believed by Aquinas. And because of that, it's believed by the Catholic Church. And because of that, it's believed by biologists when biology came into being, modern biology. It was believed in the 19th century by Charles Darwin when it would have been information evolution, you would expect things should be able to interbreed. But he continued to insist that two species cannot interbreed, and when they do, when you force them, it's always sterile. It's the most incredible biological myth of the last 2,000 years. It's fascinating, really fascinating. People are believing this against the data that's smashing them right in the face. And why? That's another fun little story, parenthetical note, sorry. And the camel family is an example. There's only 5 species of camel. Now, biologists are weird. They put llamas and camels together. There's reasons for that. They put llamas and camels in the same family. There's only 5 species of animals in the camel family. 3 species of llamas in South America, 2 species of camels in Asia. According to the fossil record, we have fossils of camels that go back for conventional dating about 50 million years. They've been separated on these 2 continents for 40 million years. Okay. Now, in evolutionary theory, the idea is that one population divides into 2 somehow. Usually, most people think that species come into being by a population being split. Each population then changes independently of the other and eventually changes so much that it can no longer interbreed with the other population. So it's now a new species. Evolution would predict that at any given time, a certain number of closely related species should still be able to interbreed. A very small percentage. You might expect maybe 1% of all the species on the planet could interbreed with another species. And predictably, if evolution is true, that should be the closest related species, the very most similar species to it. So you'd expect not no fertility, which is what Darwin did. It makes no sense because it's not consistent with the data. But you would expect about 1%, I would say, about 1% fertility, interspecific fertility.